Alkyl aryl ethers. On heating with concentrated HI gives a mixture of alkyl iodide and phenol. AR stands for phenyl group or a substituted phenyl group. In this reaction, carbon-oxygen bond between alkyl group and oxygen undergoes cleavage. The bond between aryl group have a partial double bond character due to plus R effect. Due to plus R effect of alkoxy group in aryl alkyl ethers, the bond carbon-oxygen bond between aryl group and oxygen have a partial double bond character. Hence, bond between alkyl group and oxygen undergoes cleavage. As an example, anisole on heating with concentrated HI, irrespective of the amount of concentrated HI used, the product is a mixture of phenol and methyl iodide. Phenol do not further react with HI to form iodobenzene. Hence, irrespective of the amount of concentrated HI, whether it is 1 equivalent or 2 equivalent, the product is always a mixture of phenol and methyl iodide. Anisole on heating with concentrated HI gives a mixture of phenol and iodomethane or methyl iodide. Ethers like diphenyl ether do not undergo cleavage even on boiling with concentrated HI. This molecule do not undergo cleavage because both carbon-oxygen bond have a partial double bond character due to plus R effect. Hence, this molecule do not undergo cleavage on heating with concentrated HI. Unsymmetrical ethers having alkyl groups on heating with excess of or 2 moles of or 2 equivalent of concentrated HI. A mixture of alkyl iodide are obtained. In this reaction, both carbon-oxygen bond in ether undergo cleavage. The carbon atom bonded to oxygen atom have a delta plus. In HI, I having delta minus. During the reaction, both carbon-oxygen bond undergo cleavage. The product is a mixture of Ri, water, R-I. That is, both carbon-oxygen bond in the structure of ether undergo cleavage, giving Ri, H2O, R-I. That is, the product is a mixture of alkyl iodide. Unsymmetrical ethers having primary or secondary alkyl groups on heating with 1 equivalent of or 1 mole of concentrated HI gives a mixture of lower alkyl iodide and higher alcohol. Lower and higher are with respect to number of carbon atoms. For example, methyl, ethyl, ether. On heating with one equivalent of concentrated HI, one equivalent or 1 mole of concentrated HI gives a mixture of methyl iodide, lower alkyl iodide, and ethanol, higher alcohol. The mechanism of cleavage is SN2. CH3O, CH2, CH3 is first of all protonated by concentrated HI, giving a protonated ether. This protonated ether undergo SN2 reaction. Iodide ion present in the medium selectively approaches this least hindered carbon atom. Simultaneously, carbon-oxygen bond undergoes cleavage. That is, bond making and carbon-oxygen bond breaking take place simultaneously. Iodide is a large nucleophile. Iodine belongs to 5th period in the periodic table. So it is a large group. It approaches least hindered carbon atom. That is carbon atom of a methyl group, giving a mixture of methyl iodide and ethanol. Unsymmetrical ethers having one tertiary alkyl group or benzylic group or allylic group. On heating with one equivalent of concentrated HI gives a mixture of tertiary alkyl iodide or benzylic iodide or allylic iodide and an alcohol. Suppose R dash is a tertiary alkyl or benzylic or allylic. Then the product is a mixture of ROH and R dash I. The mechanism of cleavage is SN1. As an example, tertiary butyl methyl ether on heating with one equivalent of concentrated HI gives a mixture of tertiary butyl iodide and methanol. Mechanism of cleavage is SN1. First of all, this ether is protonated by concentrated HI, giving a protonated ether. This protonated ether undergo dissociation to form tertiary butyl carbocation and methanol. This is the first step of SN1 reaction. The carbocation intermediate combines with nucleophile present in the medium. In the next step, to form tertiary butyl iodide. Another example, CH3 oxygen CH2 benzene ring, that is methyl benzyl ether. On heating with 1 equivalent of concentrated HI, a mixture of benzyl iodide and methanol are obtained. The mechanism of cleavage is SN1. First of all, ether is protonated, then protonated ether dissociate to form methanol and benzyl carbocation. Benzyl carbocation is stable, hence the dissociation takes place. In the next step, benzyl carbocation combines with iodide ion to form benzyl iodide. Similarly, if R dash is an allylic group, the product will be a mixture of allylic iodide and alcohol. So unsymmetrical ethers having one tertiary alkyl group or benzylic group or allylic group on heating with 1 equivalent or 1 mole of concentrated HI, a mixture of tertiary alkyl iodide or benzylic iodide or allylic iodide and an alcohol are obtained. The mechanism of cleavage is SN1. So depending upon the nature of groups bonded to oxygen atom as well as depending upon the amount of hydrogen halide used, different products can be obtained during the cleavage of ethers by concentrated HI or concentrated HBr under conditions of a little more high temperature and pressure. If HBr is used instead of alkyl iodide, alkyl bromides are obtained. HCl and HF do not give this reaction.